Hi Vishnuram, how are you?
I'm good. How about you?
You doing your geometry homework?
Yeah, I turned it in this week.
Hi, Priyanti.
Hi, how are you?
I'm good. How are you?
Good. Geometry problems are still hard, right? Vidyut, with respect to competition math, absolutely
Um,
hard, right?
yeah. Huh?
You'll see. Sham, I really appreciated Sham.
Oh, thank you.
What is the time now? 5:30, 5:30 or 6:30?
Yeah, it's
What's your time
5:30.
now? 5:30 or 6:30? Really
It's
appreciated
5:30.
Sham.
It's
Really,
fine.
really appreciated. Are you finding it useful, Sham?
Yeah.
Theoretical? Yes, okay.
Yeah.
Ashwik, how are you? Anish, how are you, Anish?
I'm good. By the way, we might be going to Hawaii on July 17th.
Ah, nice.
Might, so for the
Yeah,
week.
have
So,
fun there. Ashwik, how are you, Ashwik?
I'm good. How are
Oh,
you?
good, ma. How was the homework? Yops, geometry.
It was
Are you
good.
all doing alchemist?
I started it.
You started it, okay.
I'm
Did you
doing
all do
it
this?
too, but they're threatening to delete my account, so like I'm working because they deleted it already, kind of. So like, yeah, I'm asking them to like renew it because they sent an
Which one,
email.
ma?
So.
Which one, ma?
Art of problem solving. I have an account in it, and then like they sent me an email saying it was deleted, and I asked them if they could retrieve it, and then they said that I had to give them a signed PDF copy of something, so I sent it to them. It's because they said they could retrieve it.
Okay. Oh, nice. Swarit, how are you doing? Are you doing alchemist? Shyam, Ashwik, are you doing alchemist?
I started, yeah.
Sometimes.
But is there any like topics that I could do
Yeah,
like
yeah, yeah,
just
yeah.
to,
I'm going to. Can I share my screen and show you?
yeah, sure.
Because I
Because I
don't know
don't know
how.
like which topics would help in like which areas.
Yes. Um, I don't know.
Mm.
Whenever, okay, wait. Whenever I sign into apps online, it will not let me. Doesn't let me join. Do you have Alchemist? Somebody can share, huh? No, I can share. No problem, guys. Let me see. Wait. See, it doesn't sign me in at all in Chrome. I don't know why. Whenever I want to sign in, it doesn't let me in at all. Okay, anyway, I can sign into Safari, but just give me 1 minute. I really want to go over the thing with you guys. What should I do? Yep, this should be good. Okay, doing alchemist is quite important. Given the fact that we have done congruence, right? And Anish, what in algebra did you want, Anish? You wanted something in algebra, right? Anish,
Yeah, I just wanted the homework.
of algebra?
Yeah.
Okay. Let me look at it. Okay. Let me look at it and come back to you on that. Of algebra 1, you want just the homework pieces, huh?
Yes.
Of last year, huh?
Yeah.
Okay, ma. I'll check and come back to you on that. Okay.
Okay.
Now let's go over this. Alchemist.
Auntie,
Yeah, ma.
you're breaking up for me.
For the others, how is it, guys?
It's like
It's kind of
Kind-
breaking up.
yeah, sometimes it breaks up.
Yeah, it's breaking up.
Let me change. Okay, so on the alchemist front, right? Where are we? Okay. What shall we target, guys? You tell me. Tell me what are the ones that we can target for next week. Let me do one thing. Cut off my video, guys. Let me cut off my video. That might be the reason for now, but let me see. Go ahead. Is it still breaking up, guys, or are you able to hear properly?
It's not breaking up. I can hear it.
Oh, that's good. Okay. So let's go ahead and see. For next week, can we target these 4 topics, guys? We can
Okay.
even target this one. Can we
Um,
target 5 topics?
Auntie, I think we already did like a few of them.
Yeah.
Yeah, I completed the first 5.
Yeah.
Same.
Oh, that's nice. And then this one I have covered as well. Can we do these 2?
Which ones?
See,
Oh,
Pythagorean theorem, special right triangles.
okay.
Can we do
I
that?
think I think Pythagorean theorem I did, so I just need to do special right triangles.
Yeah, Pythagorean theorem. I also did.
You did?
Yeah.
But okay, so let's see. See, by today we should be able to cover these. That's
Okay.
my, so you think you can cover 3, 4, 5, 6, 7, 8, all up to 98%. All up to 98%. Would you be able to do?
Okay.
Guys, I'm asking you, you're all keeping quiet.
Yeah. Mhm.
Can I put that as homework?
Sure.
Yeah.
Okay.
Okay, so for the alchemist piece, right? I'm going to put it out as a homework. Alchemist, 8 topics in geometry. We are going to finish and share screen next week. Okay, guys, I have put down all the 8 topics. Make sense?
Yes.
Ashwik and Vishnuram, are you doing alchemist?
Yeah,
Kinda.
I have 4 of them in the blue, 1 in the green, and 1 in yellow.
4 of them in the blue, 1 in the green. I want everything to be at 98, you know.
Yeah.
Okay,
I'm working on.
can we target that? Can we target that? Okay, guys, let's go ahead now. I really want to go over. We did some constructions as well, right? Did we do constructions? Some constructions or no? Did we do constructions, guys?
I think so.
You need to tell me, guys. What did we do? AOBs, algebra. Did we do constructions or no?
I think we did.
Yeah.
Some constructions we did is what I remember. I'm trying to understand which ones we did. We are slowing down a little. Okay, AOBs, algebra. But we had the class name say AOBs, algebra, geometry, right? I'm checking, guys. Hold on. Okay. See, this is not the class, right? AOBs. Just 1 second, guys. I need to look at this. I don't have, yeah, as I said, Danish, I don't have those classrooms. I'll check later. Okay, guys.
Okay.
But I'll check later and come back to you, Anish. Okay, whatever you want, I'll help you with. Okay. So now let's go ahead. Let's go ahead and start the class now. We are just wasting time on this. Okay. Do you see my screen? You see my screen, guys?
Yeah.
Yeah.
Let's go ahead with some review. Okay, we'll go to perimeter area today. Having said that, right, before going into perimeter area, okay, I just want you to think about this. Okay, I don't know whether you've looked at this, but I just want you to think about this. Okay. Think about the earth, okay, as a globe, okay? Think about the earth as a globe. I'm sitting here in the North Pole, okay? I am
Yeah.
looking at the shortest path to Quinto Equator. This here. I want to go here, okay? Okay, for me to go there, right? I can fly straight down the 78-degree west line of longitude. Which is longitude? These are latitudes, right? This is the longitude, right? So from there, I have to take a 90-degree turn. So basically to go to Baifun. And from Baifun, again, if I have to, I'm going east, right? I'm traveling east. If I want to again go to the North Pole back, I'll have to take a 90-degree turn again. You see what I mean? So as a result, in this triangle, when you look at it, right, the sum of the angles of a triangle will be more than 180 degrees, correct? Do you see what I'm saying? Usually the angles of a triangle add up to 180 degrees. But when you think of a spherical globe and particularly traveling from North Pole to somewhere near the equator, and then you're traveling east and then going back to North Pole, what happens? This was a 90-degree turn here. You see, this was a 90-degree turn here. This would be a 90-degree turn, right? As a result, the sum of the angles of a triangle is no longer 180 degree. In case you consider a triangle in a sphere. So have you heard of the spherical geometry? Have you heard of the spherical geometry?
Yeah.
No.
Priyanti,
Uh-huh.
is this like non-Euclidean geometry?
Yes, whatever we are studying is Euclidean geometry. What is this Euclidean geometry? The mathematician Euclid came up with some postulate statements that we started accepting as is without proof, right? Postulates are also called axioms. Postulates are also called axioms. These are statements that have been, conjectures are statements. Conjectures mean just statement. We have discussed this, right, guys? Sham, we have discussed conjectures.
Yeah.
Okay. So postulates or axioms are statements accepted without proof, right? So yeah. So Euclid set up some postulates and we started accepting it and we started following his geometry, the geometry that he started discovering certain concepts. He put it out in a book and then we started accepting that. So whatever geometry we study is Euclidean geometry. However, there is one special kind of geometry, completely different type of geometry called spherical geometry, where everything is a sphere. You see, meaning we have a plane, right? We have a plane and lines on a plane, correct? Lines on a plane. Similarly, in spherical geometry, everything is a sphere. If everything is a sphere, what would happen? Let's see. A line, right? A line is no longer a line. Line becomes a great circle. Line becomes a great circle in spherical geometry. This line is one great circle. Again, if you want to construct another uh, another line, right? That also becomes another great circle. See, this is. You see, everything is a circle. The line becomes equivalent to a great circle. Okay. The ends of the great circle for a sphere, right? These points are called antipodal points. Antipodal points. The rules that the line in a spherical geometry, great circles obey in a spherical geometry is very different for lines in a plane. Make sense, guys?
Yes.
Okay. So there are so many other rules. We will discuss the differences between spherical geometry and Euclidean geometry next week for sure. Okay. It's a small subtopic, but I really wanted you to know the difference between Euclidean geometry and spherical geometry to a small extent. Make sense, guys? Okay. Now, let's leave that discussion aside. But I want you to Google what is spherical geometry and come back to class next week. Does that make sense? Okay. Okay, how about this? Okay, I'll give you an easy problem. Let's see. How do you do? 3.6, 3.27. Okay, let's see. How about this? This is an easy one, guys, but let's see. This is an easy one. You want to do this one? Quick. This is just based out of congruence, okay? We will enter into perimeter area now after a review of few problems at least. That was nice. That was nice, Ashwik and Sham. That was super fast indeed. Okay. I also wanted to cover some congruence proofs, which I did not actually. Before I go into perimeter area, congruence proofs. See, that is far more important. Yeah, guys, I really want to do proofs. Did we discuss HL congruence, guys? Last week itself, we discussed HL congruence, right? So you
I'm
did
pretty
homework.
sure.
Yep.
The homework had eight congruence.
Yeah. I really want to put proofs. Let's see. You know what? Congruence. That's what I find it difficult. Let's see.
Wait, I'm sending my answer.
Yeah, take your time.
Okay, I sent my answer.
Okay, we are going to work on proofs today for sure. Okay. Yeah, Anish, that's correct. Vidyut, that's correct. Vishnuram, that's correct. So, okay, guys, I think we'll go to proofs and then length area. How about this? Given y is the midpoint of xz, py is Swarit. Where are you, Swarit? Did you send the answer, Swarit?
Yeah, I sent it.
I missed your answer. Maybe I'll switch on my video. I don't like not being on the video. Okay. So if the audio is bad, let me know. But you know what? I can take out my video background. So that way my bandwidth is less and you'll be able to see me better. Yeah. So I should be good now. Yep. Go ahead, guys. So given y, if the audio gets cut off, let me know. Y is the midpoint of xz. Okay. Py is perpendicular to xz. Prove that triangle XYP is congruent to ZYP. Come on, guys. You're going to let me know. You help me, I'll help you. Come on, let's go ahead and write the two-column proof. Who's going to start?
We can
Statement
start
reason.
that P line PY is perpendicular to XZ.
Okay, PY is perpendicular to XC. How to start with? Reasoning is given.
Given.
Then
Y is the midpoint of XC.
Y is the midpoint.
It's given.
Yeah.
And
Then
XYP is going to be equal to ZYP is equal to 90 degrees.
from here, right?
Yeah.
Yeah. From that one, I can write XYP. Angle XYP is equal to angle ZYP, right? Equal to 90 degrees. Can I put that measure of these angles? Why? What is the reasoning? From here only I am taking that, right? What is the
Because
reasoning?
of the
Definition
perpendicular.
definition of perpendicular line segment.
XY is congruent to YZ.
XY.
Is
Oh
congruent.
yeah, XY is congruent to YZ.
And
That is
then
because
Definition of a midpoint.
definition of midpoint, correct. And then
PY is equal to YP, I think. Reflexive property.
yeah, PY equal to is congruent to YPY.
Reflexive property.
Reflexive property, yes. Now what
So
happens,
then
guys?
triangle, yeah.
Yes.
XYP is congruent to ZYP by how?
SAS.
Oh, nice, guys. You're all awesome. Okay, so we are good with this proof, right? So I want to work on with 4 or 5 proofs at least today, okay? So proofs is so important. Let's see. You know what? I don't know why is this written down like this. Give me a minute, guys. One second, guys. You're going to wait a minute, okay? I don't want an edited document. I don't know why I'm having that. I don't know why. What is this? One second, guys. Non-congruence. Okay, how about this? Let's see this one. You're going to prove this, okay? We are going to write out this. Now, here is the figure. You can tell me one by one. So that's the figure. We are going to do this proof. Go ahead and tell me how to prove.
A, wait,
Vertical
C.
angle?
AB bisects CD.
Yeah.
AB?
Wait,
AB
definition of
bisects CD.
perpendicular lines, like because AB is perpendicular to CD.
Or
AB is perpendicular to CD, okay? Let's do, see, first let's go with given, please, guys. We'll go follow the order. So what first? AB is perpendicular bisector of CD, given. Okay, and then Anish, are you participating, Anish?
Yes.
Okay.
AD is congruent to
AD
CD.
is congruent to CB. Yeah, given. Now what?
AKD is equal to BKD.
Let me mark it. AD equal to CB. AB is the perpendicular bisector. Oh, wow. Okay.
So
AB is the perpendicular bisector means this is, oh, I'm sorry. I think I did it wrongly. Okay, go ahead. Then perpendicular bisector means this is also equal, right?
yeah. And then
No. Because of this, let's do what is that? AB is the perpendicular bisector means what? We need to be slow, but how? What?
DK is congruent to KC.
Okay, let's
CK.
write down DK. Let's write down DK is congruent to CK. How? Why?
Perpendicular bisector.
Definition of bisector.
Mm-hmm.
There's nothing to do with perpendicular there, right?
Oh, yeah.
Then what next?
DAK is equal to CBK.
D?
Wait.
Yeah. Measurement
DAK.
of DKA.
CKB.
Tell me.
If it's DKA, then wait, what?
See, you cannot write directly DKA is equal to. Yeah, you can, but you have to write the reasoning.
Vertical angles.
BKAA.
DK?
BK equals to KA.
DKA. Okay. I agree. DKA is congruent to CKA. Why?
The hypotenuse leg
Both of
congruence.
them are.
Go ahead. Why? What is the reasoning?
The
Perpendicular.
Definition of perpendicular segment. See, from the given only, I'm writing that. Okay, it's a sequential, logical sequence of statements. Definition of perpendicular. Then what? And then I can write measure of DKA is equal to measure of CKA. This is the nice way of writing it. First you write the congruence and then from there you say measures. This is how you perfectly write proof.
You're breaking up really
Go ahead,
bad.
I'm there.
You're breaking up really bad.
Breaking. Yeah. Hold on. Let me switch and see. I want to switch and see as well. I don't know. Maybe I'm going to switch off my video, guys. I think that was much better, right? Let's try this. Go ahead. Next one. Keep going, guys.
They're congruent because of the hypotenuse leg congruence.
Which one?
The hypotenuse leg congruence theorem.
Good. Okay. See, in that case, I don't need to prove that these two are congruent, right? Why should I prove? Okay, you want to do the hypotenuse leg congruence theorem, that is fine. But why would I want to prove these two angles are congruent then? Ashwik, the problem with the way you're saying is these two angles are congruent. Okay. These two angles are congruent. Okay. I get it. Okay.
Yeah.
But how did you prove that this angle is a 90-degree angle?
Wait, vertical angles?
Yeah, you can say vertical angle or you can say, see, congruent supplements theorem, remember? Meaning, suppose let's say this is angle 1, 2, 3, okay? You know angle 1 is equal to angle 2, right? Is equal to 90 degree. Now, angle 1 plus angle 2 is also equal to 180 degree, you know. Why you know? Because it's a straight line CD, right? Similarly, angle 2 plus angle 3 is also equal to 180 degree. So, when you think about it, right? Angle 1 and 2 are supplements. Angle 2 and 3 are supplements. In that case, what you can clearly say is congruent supplements theorem. 1 is equal to 3. You get it? 1 and 2 are supplement. 2 and 3 are supplement. So 1 is supplement to 3. 1 is equal to 1 is congruent to 3. That's the conclusion you make. That is because of congruent supplements theorem. Okay. So otherwise as well, vertically opposite angle is the easiest way. Okay. So here definition of perpendicular DKA. Okay, those two, dKA is equal to CKA. dKA is equal to CKA is 90 degree. And then what did you say? Then that is also not required, right, guys? This is also not required if you want to go the route of HL congruence. Definition of bisector. So you said that it's bisecting, okay, and then AD is equal to AD. The hypotenuse is equal and this is congruent, you said. And after that, you just say AKD is congruent to CKB. What does it mean? Vertically opposite angles, right? That's so easy a proof. Now, AKD is congruent to CKB. Measure of AKD is equal to measure of CKB. Definition of congruent angles. Definition of congruent angles. Is my audio okay, guys?
Yeah.
The video was the problem. Okay. So AKD. Now what happened? So this we proved, and these two are 90-degree angles we have proven as well. Oh, perpendicular is important. Wait. For us to prove perpendicular was important. See, because we have to prove that this is 90-degree angles, right? AKD. AKD is okay. We need to say AKD is equal to 90 degrees. That's because definition of perpendicular. AKD, right? Because definition of perpendicular, definition of perpendicular line segment. AK is a perpendicular line segment, right? So AKD is equal to 90 degrees, great. AKD and AK is, this is okay still. Then what, guys? What else next? What else? It's a right angle we have proven, and hypotenuse is equal to hypotenuse, leg is equal to leg. Finally, what is the statement? Triangle.
CKB, triangle
Triangle
CKB is congruent.
CKB is congruent to,
Triangle ADK because of hypotenuse leg congruent.
yep, triangle DKA, I can write, right? That is because HL congruence. Now what? That's it, right? That's it. Can I move on? So you should be able to write proofs like this, meaning easily. Okay. Let's try one more. I think with this we'll go ahead. HL congruence definition of, yeah. You just need to prove everything. Whatever is needed, you have to prove. How about this, guys? Okay. Let me give you the statements as well this time. Okay. Now you're going to write the reasoning. Anish, can I get answers from you this time?
Yeah, I'll try
Yeah.
my best.
Yeah, sure. You know, Anish. Go ahead. Let's write the reasonings.
Okay.
Try.
It's given.
Given.
Number
Okay, then next one.
and number 2 given.
Number 2, given.
Given.
Okay. Then Q is equal to 1.
Given,
That's not given.
but like
Corresponding angles, I think, will be like
Hmm?
it might be those wait,
What is it?
no, and and they're like same size, no, like Q and 1.
True. What is the type of angle? Correct. Why? Yeah, I know, I understand. Okay, ST is parallel to QR is given. But why would angle S is equal to Q?
because of like cars,
Hmm.
It's
interior thing, the
Now,
corresponding
what is
angles.
the type of angles, guys? Corresponding angle postulate.
Yeah.
Yeah, you cannot forget. Then 1 is equal to 2. What is that? 1 is equal to 2.
And then it got
1 equal to
Why 1 is equal to 2?
because that there it's also the first PST is an isosceles triangle.
Exactly. So how do you say that?
Isosceles triangle.
Yeah, angles opposite to equal sides in an isosceles triangle are equal. So that is the isosceles triangle theorem. And then what? 2 is equal to R.
So then that's corresponding angle postulate.
Corresponding angles, yes, corresponding angle postulate. Then
You and I
For 6,
Q is equal to R.
Isosceles
yeah.
isosceles triangle theorem.
No.
It's
Q
Um,
is equal to R. Nobody said that Q is equal to PR.
Transitive.
Q is equal to R. Why would Q be equal to R?
because 2 is congruent to R. But
What is it?
Transitive property of congruence.
Transitive property. I like that, Vishnuram. Why transitive property? Here we go. 1 is equal to 2. 2 is
E-
equal to R.
R.
E-
Transitive property.
And then,
Nice.
yeah.
Derive it from the previous step. Okay, then last PQ equal to? PQ is equal to, yeah, what is that? PQ equal to, what is the reasoning? PQ equal to PR, what is the reasoning? Isosceles triangle theorem.
triangle theorem.
Makes sense, guys? Yeah. Okay, so you should be able to write details of reasoning very nicely. Okay, so this one I'm going to give it to you as homework. Okay, you should be able to write all the proofs. Okay, let's see one more and then we'll finish with that. Okay, how about this? You know what? I don't want you to. One second, guys. Let's see. Yeah, these are good. Let's see. Can we do these two? We'll do two and then move on. Okay. See, these are not in the book, guys. Okay. We need to do, if we really want to do good in geometry, I really want you guys to be able to do this as well. Okay. These are extras. Okay. How about this? But we are going slow because of that. It's okay. Go ahead. Okay. See, I'll give you time. You think about it. Okay. Then we'll do both the proofs.
Can I go to the bathroom, Priyanti? Please?
Yeah, yeah, yeah.
Thank you.
Go and come. Let me know, guys. Shall we get started? Did you think about it?
Hmm.
Can you write the proof? Go ahead, guys. What should we do? Anish, Ashvik, you
Yes.
can get started.
Okay.
Anish or Ashvik, get started. Amma, please, let's go ahead, ma'am.
Yeah.
Anish, Ashvik, are you there?
I'm thinking still. I'm still
Amma,
thinking.
please don't switch off the videos, ma, for sure. You guys lose accountability, okay? But for my internet, I would not switch it off at all. Go ahead. Anish, go ahead. What is the first step?
The first step, I'm thinking
Mm.
um,
What do we start with? Any proof will start with what? Go ahead,
um,
ma'am.
any proof starts with,
Okay, Vishnu Ram, you want to help us?
Our AC bisects DB. It's given.
Okay, AC bisects DB. Yeah, it always starts with whatever is given. Then the next one,
um,
AC is perpendicular to
AC is perpendicular to DB.
given. Then what? From
AE,
here,
AED and AEB are right angles.
good. AED and AEB. So
C,
AED and AEB.
CEB and CED are right angles.
Their
Huh?
definition of perpendicular angles.
Yeah, that is also there. Yeah. 1 minute. 1 minute. But what do we need? AD and AB are equal. This is what we need to prove. We don't need to go into the rest, right?
Okay.
That one, the reasoning's
So
definition.
now I can say measure of AED is equal to measure of AEB. First of all, why they are congruent? They're congruent because perpendicular, right? Okay.
Yeah, definition.
How do I write that?
Definition of perpendicular angles.
Then I can't write it like this. Wait. So AED is congruent to AEB, and then that is equal to 90 degrees. Okay. So definition of perpendicular.
Yeah.
Okay. Definition of perpendicular line segment. Okay. Mm-hmm. And then what?
DE is equal to BE.
AC by 6 dB. What can I say about it? What can I say about it? AC by 6 dB, right? So can I say DE is equal to EB?
Yeah.
Can I say that,
Yeah.
guys? Why definition of
Bisector.
bisector? Then what? What's the last one?
Mhm.
See, think about it.
A
We told about the
angle
angle.
ADE
We told
angle
about the sine.
angle ADE is equal to angle ABE.
No,
Mm-hmm.
nobody says that.
Okay.
See, it should be a logical sequence of statements, right? AC bisects DB. That was given. These two were given. From the given, we arrived at the next two, which is good. After that, what is needed to prove AD is equal to DB? I just need to prove AD is equal to AB. What is needed for that? You're going to tell me, guys, please.
SAS.
Correct, ma. But what is missing for SAS? Correct. But what is... So what you need to do?
Oh, wait, the middle side, like the AE.
Correct. AE is reflexive to EA.
Oh.
Reflexive property of equality. And then you can say, what is the next one? Triangle ADE is congruent to triangle ABE. Why? SAS congruent. Yes. And then how do you prove AD is congruent to AB? Why?
CPC to C.
You want to try writing the proof for the next one? Proof will come only with practice, guys. The more you do, the better it is. Let's try. Statement reasoning. Anish, I would like you to try, Anish. You're switching off the video, Anish.
It's off?
Yeah.
Oh.
What's
It's
the state?
on
Okay.
for anything.
Now KGH is congruent to KHG. 1 second, guys. Sorry, guys. Go ahead.
Okay,
Go ahead.
now you can
KH.
see. Now
Go
can
ahead.
you see?
Yes, Anish.
Okay, good.
Hey, auntie. I have an idea. Wait.
FG is equal to GH,
JH.
and FK is equal to JK.
Okay, I can write. Which one should I write first, guys? I'm okay with anything.
KGH congruent to
Okay, we will write
KHG.
that first. KGH is congruent to KHG.
FG is congruent to JH.
Okay, let me mark that. KGH, KHG. Otherwise, I won't understand. KGH, KHG is congruent. JH, right? FGJH means FGJH. Okay. Then can I write FKJK?
Yeah.
FKJK. Mm-hmm. Then what do I do? Then what do I do?
Wait, what? KGF? Wait, what? KGF is congruent to KHJ?
KGH is congruent to KHG. I wrote. Whatever is given, I wrote.
KG is equal to KH.
Oh, yeah, yeah. KG.
What am I?
KG is
KG,
equal to
KH.
KH.
Why?
Wait.
Nobody said that.
Isosceles triangle theorem?
KG is equal to wait, no, sorry.
It's not isosceles triangle theorem, right? Hey, Vishnuram, how are you saying isosceles? I don't get it. What are you saying? KG?
I don't know. Is it not equal though?
No.
Is
You have
that
to have some defense, right, to say that? Okay, for you to say that KG equal to KH, right, Vishnuram?
Yeah.
This angle should be equal to this angle. Is it? No, right? You
What is
see
it?
what I mean?
Alright.
It kind of looks like a side angle.
Yeah, but side angle is not congruence, right?
Yeah.
K bisects FJ.
Hmm?
Isn't that already said?
Hmm.
This is a good one. F is equal to J is what you need to prove. Mm-hmm. Think about it. Let's see.
Isn't it getting like mirrored?
Is it getting?
Like mirrored on one side? Because like if HJ and JF are equal and KJ and FK are equal, then shouldn't and
Guys, did they say that KGH? Oh my God, yes. I marked it wrongly, guys.
Yeah,
Yes,
I,
yeah, the angles are equal. So
yeah.
that's what I was thinking, but
KG equals
You just
KG.
tell me bluntly, right? Auntie, you marked it wrongly. If I am wrong, I am wrong, right? KGH is equal to KG. Now tell me.
Yeah, KG equals
I'm
KH.
with you all. Good job. Okay, so from this, you can say, what I
K
can say?
SSS.
KG is congruent to KH.
KG is congruent to KH,
KH.
right? Isosceles triangle theorem. Mm-hmm.
And then it's SSS.
Yep, that's it. That was so easy, right? Which is congruent to which? You tell me. Tell me the order. That's also important, right? Knowing to write the order is important, guys. G, F, K is congruent to what? Come on, guys.
HJK.
H, J, K. Good job.
Mm.
See, because one line goes to two double bars, right? So like that, H, J, K. That's how I do it. Okay. So this is SSS congruence. Then F is congruent to J is CP. Makes sense? Yeah.
Yeah.
Okay, the rest of the proof you do it at home, guys. It's taking a long time. Is this okay for you all to write proofs at home?
Yeah.
Yeah.
Okay. Okay, but please do, okay? So now let's go to lengthen area from the book. And I really wanted to do this. I don't know if I can do. Don't know. Let's see. Wanted to do only this one. Okay. Okay. Would you okay. I would really like, okay, let me see. This is the only problem I want to do, but I don't know. Let me see. This is one review problem from the book I wanted to do on congruence, okay? Do you want to try? All four angles of a square are 90 degrees. And all four sides are the same length. Square EFGH is inscribed in square. ABCD as shown in the right, meaning that each vertex of EFGH is on a side of ABCD. Show that AHE, what to show? We know that these are 90-degree angles. Now, okay. Now, AHE is equal to AHE. You have to prove AHE is equal to BEF. How do you prove that, guys? Think about it and let me know. How shall we prove? Did you get it? Guys, let me know. What do we do on that? Guys, are you all with me? Are you thinking?
Yeah.
You tell me,
Yeah.
guys, otherwise we'll do it together. You want to think? Okay.
Wait, angle AEH, HEF, and BEF form a
Let's go ahead.
straight.
Let's go ahead and write down. Let's go ahead and
Yeah.
write down. What do you want to what do you want to say? Let's
So
be very
you see angle AEH, HEF, and BEF, like
okay,
on the
let's write
top.
down. Okay,
Like,
let's write down. AEH
yeah, and
plus
then HEF,
HEF. Okay, that's a good one to start with.
and then
Plus FEB
BEF.
is
Yeah,
equal to what?
180 degrees because they're on a straight line.
Nice. Then, so
Uh,
he's saying this plus this is 180. Correct.
yeah,
Then,
yeah, and then HEF is 90 degrees because
okay. So what? So that brings up AEH plus FEB equal to
Plus,
90 degrees.
yeah, and then that plus 90 is 180, but um,
Now what? AEH and FEB. This and this match up to great. This and this add up to 90 degrees. Then what? Okay. Can I give you one clue?
yeah.
This is a little, see, that's why I picked up this problem from the book. I want you to do all the review problems in the book. Consider this triangle and tell me what is a 180-degree angle. So you will get something else there. can I say AH,
AHE and AEH.
AHE plus HAE plus AEH will be equal to 180 degrees. You know, angle AHE, this one is 90 degrees. So what? AHE plus AEH equal to 90 degree. That is the clue. Now you do.
Oh, wait. So AEH plus FEB equals AHE plus AEH.
Can I equate
So,
both?
Yeah.
so AHE is going
FEB
to
equal to
FEB.
And then wait,
AHE.
cancel out the both the
Exactly.
A, and
AEH.
so and then FEB equals
The
AU.
Yeah, guys.
AHE.
FEB. Did you all get it?
Yeah.
Yeah.
This is how you prove. Okay. Do you want to take the second one home for the homework?
Sure.
Or do you want to do it here? You tell me, guys. Anything is okay for me.
We could do it right
We
here.
could do it here.
You want to do it right here? Okay.
Sure.
Go ahead. Go ahead.
All the like you see the hypotenuse of the triangle? Like all the triangles?
Mm-hmm.
Like they're all equal because it's part of a square.
Correct. Huh?
Yeah,
So,
yeah, they're all congruent.
okay, let's write down. He has some thoughts. Let's write down. What is that thought, Vishnuram?
So the hypotenuse of all the triangles are equal.
Oh, so you're saying, okay, this is for
Like
5D.
yeah, yeah. So like
Okay, the
HG,
You're saying EH is congruent to EF, is
yeah,
congruent to
Which is to
FG,
FG and
is congruent to
FG.
GH. Okay, so
yeah.
what?
I don't know. I just saw it.
Yeah, that's true.
Wait, so and then all the corner angles, like you see angle A, B, angle C. Yeah, they're all 90
then
degrees.
Good job. Very nice. A is congruent to B, is congruent to C, is congruent to D because they're all 90-degree angles. Then,
What would that make EF?
see, we did prove that this is equal to this is equal to this is equal to this, and we also said that these are 90-degree angles. What else can we prove? From here, we can take something too.
AE, so all the acute angles.
AEH is equal to what? AEH is
B,
equal to
BFE.
BFE, which is equal to
BFE, correct. BFE
Yeah,
is congruent to
CGF,
CGF
CGF. Yeah, CGF.
and GHD.
And yeah, DHG, yeah.
THG. So what happens here? So what? Yeah, you got it already. So what? Go ahead. That's all. So
Wait,
how
so
do you say
so
these are
What
all
is
congruent?
so
angle side?
AEH equals
A
BFE.
angle side because of the
Because
Yeah,
of
corner angles and
correct,
then
correct.
the acute angles. Yeah,
it's
and
ASA.
Yep.
then
A
AAS.
Anish, are you following?
Yes.
AEH is congruent to BFE, is congruent to
Yeah,
CGF, is
CGF
congruent to
and
DHG
DHD
because angle
ASA.
side
angle
congruence.
side.
Got it?
Yeah.
Wait, isn't it ASA?
No,
This
because
is
the right angle, the acute angle, and then the side in the inner triangle or inner square.
What was that? I didn't get you. What was that now?
isn't it ASA congruence? Yeah, ASA.
It's not ASA, right? A is
Two
two
angles
angles
and
here,
then one
two
side.
angles and one side, right? AAS, right?
Alright.
You got it?
Yeah.
Yeah.
Did you get it?
Yeah.
Can we move on?
Yeah.
Yeah.
Now let me take this off. Okay, now I want to go to perimeter area. Is that okay? Can we go to perimeter area? Let's see. I want to go to Yeah. See, there's a lot of nice challenging problems in the review problems as well as challenge problem of chapter 3. I would really, really, really want you to try. Can we try, guys? Okay. How about this? Okay, how about this? Do you know how to find the perimeter of this? Find the perimeter. These are easy ones, guys.
Mm-hmm.
Let's do this one as well. These are easy ones, okay? This you can do by yourself. Only thing is, we have done it's a special right triangle on the first one. Second one, it's not a special right triangle. Sixth. Let's see. 4.2. First one is easy, right, guys? Isosceles triangle theorem makes it 8 and 8 on the sides. So 8 plus 8 plus 8 root 3. Can I move on?
Yeah.
Okay. Then the second one, the length of each leg of an isosceles triangle is 3 times the length of the base of the triangle. So what you need to do, you have to frame equations. Would you be able to? I would like to get answers from all of you because the class is so low now. Go ahead.
I gave you answers for both of them, Priyanti.
Wow. That's right, Vidyut. Mm-hmm.
I also sent my answer for the second one. I believe. You should have it now.
Sure. Okay, this is a good one to do. I really want you to try this one. See, you know triangle area is half times base times height, right, guys?
Yeah. Is my answer right? I sent it for the
Answer is, can I shout out the answer? Vishnu Ram correct. Anish correct. Ashwik correct on that one. Ashwik, what is the answer to this one, Ashwik? Shyam correct.
Yeah, I'm doing the second.
Yeah. Do it, and the rest of you can proceed with this. Given that angle ZXY is equal to XWY. Given that ZXY is equal to XWY is equal to 90 degrees. Can I help you on this, guys?
Priyanti, isn't this geometric mean?
I really like your way of thinking with you. That geometric mean is so important to geometry, but we have not covered it. So it is very simple than geometric mean. I
Okay.
really like your thought. Yes, as soon as you see those two as soon as you see a right angle within a right angle, this is a right angle. There are two right angles within the big right triangle, right? Immediately, geometric mean has to strike you. Great. Okay. But then we are not yet there. So this is pretty simple. It's just length and area. Guys, there's not much to think on this, honestly.
I
How
sent
to
my
find out?
I sent my answer.
Oh, you sent your answer?
Yeah.
I don't know what is answer. That's right. Can one of you explain? Two of you got the answers, right? Go ahead. Who wants to explain? Go ahead, go ahead, Vishnu Ram or Ashwik, any one of you.
I have to go get the door. Can I?
Go, get and come quickly.
So I tried finding the area of ZXY, and I got 24.
Good. Area of
And then,
ZXY. Area of
and
ZXY
then,
can be represented using this.
yeah, and then I found the area formula with the hypotenuse ZY and the altitude
24
XW
equal to ZY times half times.
of XW.
Yep.
And then I solved for
XW.
XW
This is
and I
what?
got 4.8.
ZY is 10,
Yeah,
right?
so I did
So 5W.
yeah, so I got 24 equals to XW times 5. I divided both sides by 5 and I got 4.8.
Yep. So XW will be equal to 24 by 5. Make sense?
That's what I
Wait,
did.
can you explain it again? I didn't get it.
Okay, no problem. Okay. What did I do? Sorry, guys. Okay. So here we go. Area of the triangle is what? Instead of writing that, right? I'll write geometrically. Okay.
Mhm.
XYZ will be equal to half times 8 times 6, correct?
Mhm.
Right? 24 square units, correct?
Mhm.
Correct? Now
Yeah.
the same area can be computed using
Hello, I'm back.
XW times half times ZY will be equal to 24. Make sense?
Mhm.
Yes.
XW times ZY is 10 times half is equal to 24. 5.
Oh, so it's 24. Now I get it.
Got it?
Thanks.
No worries. Can I move on? Can I move on, guys?
Yeah.
Okay, how about this? See, it's so wonderful if you have two triangles sharing the same altitude. That's a concept that I want you to try as well. Let's see. How about this? Mm, yeah. See, given this, see whether you'll be able to find the area of any triangle. Given this, right? This is just a conceptual understanding problem. Okay. For this problem, right? Do you know? Find the area of triangle DEF. Okay, given that DJ equal to 8, it's perpendicular, and EF equal to. This is easy though. This is easy, finding the area of the triangle. But after finding, do you know how to find the area of any triangle? Do you know how to find the area of any triangle?
Like the Heron's formula.
There are no, you don't need to go to Heron's formula.
Oh, okay. Like half base height.
Yeah, see, the bigger triangle area is very easy, right?
Mhm.
Mm-hmm. DEF is very easy. What is the area of DEF?
28, I think.
Yep. How do you find XYZ triangle area? How do you find XYZ? XYZ is there, right? XY. Oh, you don't have. Okay, wait. Altitude is also called the height. You all know that, right?
Mhm.
Mm-hmm. Area of DEF, given that, okay, find a method to determine the area of any triangle. Okay, 1 second, guys. I really want you to, you can't do it from there. Hold on. Find the method to find the area of any triangle. 1 second, guys. Let me. Okay. I want you to try this one actually. Let's
Wait,
see this one. No, wait,
Riandy
guys.
and
Yeah.
Priyandy,
Yeah,
can I
ma?
just please go get my charger?
Go, get and
Okay.
come. Okay. See, guys, here it's easy to compute DEF, the area of the triangle. It's easy to compute, right? How do you compute? 8 times 7 divided by 2 is easy. Okay. However, let's say one of these angles is obtuse. See, since E and F are acute, it's very easy because even if you consider DEJ, if you know for DEJ, right? If you know EJ, for DEJ triangle, EJ times DJ divided by 2 can be done. But here E and F are acute. Let me show you a scenario where it is difficult to find the area of one triangle. So that is where, let's check this out. What is the formula for such a triangle like this one? You can draw auxiliary lines. You can draw auxiliary lines. What I meant to say is I'm going to draw up a perpendicular. Okay, let's call it P. How do we do that? Mm-hmm. Shall we try finding the area of this triangle? We are just finding the area of an obtuse triangle. If this is the case, let's see. Here, what we can do, the height is outside the triangle. Still, the area would be xp times yz divided by 2 will be equal to the area of xpz. Any questions? But xp times yz can be written as pz minus py. Pz minus py divided by 2. Can I write it like that? Are you all with me, guys? Are you all with me?
Yeah.
Now, pz minus py is what? xp. xp times yz by 2. See, only thing what to notice here, the only thing I want you to know is even if it is an obtuse triangle here, even if it is an obtuse triangle, okay, just tell me how will you find the area? If you already know the formula, this is not required at all. What is the area of this triangle? Anybody can shout out. What is the area of that triangle? Same, use, I think you all know this already, guys. What is half base times height?
Huh?
What is the height and what is the base here? That's all I want to know.
ZP. Wait, no. Mm.
See, that's what, don't get confused with the base. Which is the base here?
ZY?
ZY is the base, correct. Even if the height is outside, your base is just this. That's all I want you to know. Half times YZ times PX. Does that make sense?
Yes.
Even if the height is outside the triangle, you can still have the area to be that height times your original base, not the entire base. Okay, that's all. Okay, let me move on. Okay, how about this? Okay, how about this? This is a good one. Let's see. Yeah, guys, this one was very good. Let's see. Yeah. How about this? See, this is where you enter into the concept of two triangles having the same height. Two triangles having the same height is very interesting. Two triangles having the same height. You can really do wonders with two triangles having the same height. You see, same height or same base. Given that BC is equal to 40, CD equal to 20 in the figure, what are ABC? Area of ABC by that square brackets indicate area of ABC by ACD. Let's try. You try and tell me. It's not hard. You can draw auxiliary lines. Auxiliary lines are That's the height of the triangle. Go ahead. What is the area of triangle? ABC. Divide by ACD. Do you want to try, guys? I also want to know 2 different problems are there. Go ahead and do that. You can substitute H as H. You'll just be fine because you're going to find the area ratio. So you want to try that?
Mhm.
You want to try, guys, or you want me to try? I can go ahead and try. You want me to show you? What is the triangle? What is the area of triangle ABC?
I sent my
Half times.
answer.
Okay, that's nice. Half times.
Base height.
Base height.
Base times height. Which is the base? Which is the height? There's nothing much about. There's
40 of
nothing hard.
each. Or well, for ABC, it's 40 of the base.
ABC is 40. Good. And then what is the
H,
height?
H. And then
ACD, half
half of
time, 20
20.
times. H, yeah, H and H get cancelled. So the ratio is 2. Good job, Vidyut. ABC by ABD. That's also easy, right? Half times 40 times height. Divide by ABD, right? ABD.
So would it be 1/2 times 60 times H?
1/2 times 60 times H, correct.
So
So
2
it is 2
degrees.
by 3. Make sense? So
Mhm.
sometimes that H, if it is common, right, it can get cancelled, okay? Sometimes if the base is common, it can really get cancelled, okay? We'll do more problems. You'll get to know more. Let's see this one. I had picked out some problems. Let's see this one. You're going to do this, okay? I've given you the clue, okay? When there are 2 triangles with a common base or a common height, don't worry about it. You can just keep going with a B or a H. And when there are ratios involved, it's even easier because the H and B will get cancelled as well. So here, find the area of ADX. Find the area of ADX. This area you need to find. You want to try or you want me to try? I've given you the clue. You have
I want
to
to try.
go with there are 2 triangles with a common height. There are 2 triangles with a common height. They have given the area of ABX as 24. ACX as 15. Want to try?
Mhm.
Mm-hmm. ABX by CBX. Do you want to compute? Area of ABX by CBX. You can compute it. And that is equal to what? Because they have the same height. See, ABX and CBX have the same height. Similarly, ADX and CDX have the same height.
Is my answer right?
I can check now.
Ah.
What was the answer? Let me check the answers. I'm checking. Good job, Vishnuram. Ashwik, nice. You guys want to share how you did, or you want me to share? I'm going to consider. Mm. Go ahead. You want to share, Vishnuram or Ashwik?
I can explain.
Yeah, go ahead.
So first I played I understood the triangle area property.
Mm-hmm.
So ABX and BCX have the same height from vertex B.
1
So
minute. ABX and CBX, right?
BCX.
ABX and BCX. Good job. ABX and CBX are in the ratio 24/15 as well, right?
Yeah.
Go ahead.
And then so I applied the ratio to the other side since they share the same height as vertex D.
8/5 will be equal to AX by CX. This you derived?
Yeah.
Next, what did
And
you
then
do?
I set up the equation. So ABX multiplied by CDX equals to BCX multiplied by
Okay, for
ADX.
this triangle, what did you do? For the next triangle, can we do that?
Yeah.
Yeah, what did you do? ADX triangle area divided by XDC triangle area will be equal to what? Half times AX times, this is your height, right?
Yeah.
Can I say it as T divided by XDC is half times XC times T, right? Half and T will get cancelled, right? So the area of ADX and XDC will be equal to what? AX by CX, which we got in here. We can plug that in here, right? And what else we know? We know CDX area, right? This is 10. This is 8/5. So area of ADX divided by 10 equal to 8/5. So area of ADX will be equal to 10 times 8/5. Is this what you did, Ashwik?
I did kind of a different way.
How? Tell me.
So I substituted the given values and solved it. So 24 times 10 equals to 15 times ADX.
24 times 10 is equal to, why 24 times 10 is equal to 50? Yeah, 24 times 10 will be equal to?
15 times ADX.
Correct. But how did you arrive at that? That's the same thing as this, right? But how did you arrive at that? 24 times 10 will be equal to 10 times area of ADX. How did you arrive at that?
Let me check my work.
Hmm?
Let me check my work and see how I did it.
Guys, Swarit, did you follow the proof here? See here, the red triangle, right? The two triangles inside the big red triangle have the common height, h. Similarly, the two triangles inside the purple triangle, right, have the same height, t. That is the best part. So when you write out the area ratios, right, several of them will get cancelled and you end up with the base AX by XC will be equal to that is the best part. So the base ratio, right, the base ratio of triangles that have the common height. The base ratio means this ratio by this ratio. Those two triangles, when you think about it, those two triangles are the common height. So the base ratios, this is what it is, AX by CX will be equal to the ratio of their areas. So that is 8/5. Similarly, the same base ratio 8/5 can be applied to the area ratio here. You need to find one of the areas, ADX, right? So you need to find this area. So you already have you know that for triangles with the same height, the area ratio is equal to the base ratios, right?
Yeah.
So you can find this area by
By
the ratio
doing
of the bases. Yep.
ADX and CDX.
Yep. You got it?
Yeah.
How about Anish? Shyam, did
I
you get it?
understand. Yes, I understand now.
Yeah, I get it.
Okay. So that's interesting though. Same base, same height is really interesting in geometry. How about you can do the rest of it at home, I think. Let's see. I didn't do any review problems in this chapter, guys. It's almost a chapter. Okay. Now, have you come across similarity of triangles, guys? I'm not in a hurry,
Yeah.
but have you come across similarity? Okay. Now, here, right? If I say, okay, this one I want you to really understand. Let's see. Okay, let me ask you this. Mm, no, I really wanted to be able to do this one. Let's see. How about this, guys? Between these two triangles, right? Let me draw these two triangles for you. Okay. Similarity is very similar to congruence, okay? Meaning, in congruence, you had SSS, SAS, AAS, ASA, correct? What congruence was not there? SSA was incorrect. Makes sense, guys?
Yeah.
In similarity, what we are going to do is, we'll do the same thing, okay? We have, what similarity we have? We don't have SSS similarity. So basically, we'll have SAS. Okay. The main thing in similarity that comes into picture is AA similarity. If two angles in a triangle are equal, when two angles, see this angle is equal to this angle is equal to this angle here, right? So when two angles of triangles, two different triangles are equal, then the triangles are similar, okay? Meaning this can be small size, this can be big size, but you know what? The angles are similar. The angle cannot extend because some of the angles in a triangle is always 180 degree. Angle cannot have scale factors. You got it? The sides will have scale factors. This is x means, let's say this is a times x. This is y means this will be a times y. This is z means this will be a times z. In this case, a is greater than 1. Suppose this triangle got shortened like this, xyz. Again, ax, az, ay, it can be the scale factors there. But then here, a is less than 1. Any questions?
No.
Okay. Okay. Suppose when two triangles are congruent, what is their scale factor, guys?
1.
1. Good job. No, let's go ahead. Let's try this one. So, how about this? Okay. Do you think you can do this? You're going to try. We just discussed A similarity. We didn't do anything else in similarity, okay? You have to defend yourself. Whenever you claim something, you have to defend yourself. Let me see. What did you find? Okay. But I did not tell you the concept of similarity, I feel. Let me show you. A, B, C. Okay. I want to write it out as D, E, F. Okay. Now, I'm saying triangle ABC is similar to triangle DEF. See, this is similar. This is congruence. Okay. Now, guys, what happens? AB side is related to which side? Who can tell me? AB side is related to EF or FD or ED?
EF.
No, not from the figure. Don't say it from the figure.
DE.
Ah, yes. AB. See, here they are not congruent, right? So we write ratios. AB by DE. AB by DE will be the scale factor. Correct, guys?
Hmm.
Yeah.
That
Yeah.
scale factor will be the same as
BC and E.
BC by EF. See how deceptive it is. Don't go by the figure. BC by EF. That will be equal to what? What is the last one?
CA and FD or
AC and FD.
EF.
See the order of the letters. Did you get it, guys?
Yeah.
In similar triangles, the sides are proportional. They are not congruent. The sides are proportional. Now, angle A is congruent to what?
Angle
Angle
D.
A is congruent to
Angle D.
angle D, order of the letters. Angle A is congruent to angle D. Angle B is congruent to
Angle E.
angle C is congruent to
Angle F.
F. So the concept of similarities are slightly different. How? Why? Angles are equal, but the sides are not equal. They are proportional. You got it? Now,
Yeah.
now if you switch this, right? DE by AB, if you switch, what would happen everywhere? EF by BC, AD by AC. Did you get it, guys? However you want, you can switch. Or you can even switch like this. AB by BC. You can write AB by BC in the same triangle. Go to the next triangle. AB by BC is equal to what?
DE
AB
by
by
EF.
BC is equal to
DE by EF.
DE by EF. You should be able to do it based on the order. Anish, did you follow? AB
Yeah.
by BC is equal to DE by EF. Did you
Yeah.
get it?
Yeah. I understand. Like I said like C equals to F.
Okay, now the lengths in the triangle are marked. WX is parallel. This is parallel to this. Now just tell me quickly what is PY.
There.
Mm-hmm.
Oh.
Go ahead. Which triangle is similar to which triangle here? Can I show you? WXP is similar to what? Guys, these two are parallel lines. So what?
YZP.
Hmm?
Or wait, ZYP.
WXP is similar to,
ZYP.
is it not YZP? Because a parallel line is marked like
Did you
this.
say okay, WX?
YZP. The order is so important, right? Okay, go ahead. So what? How do I frame it? WP by. Go ahead. Okay, is this getting tougher? Do you want to discuss similarity next week, guys?
WP and ZP? Or no, WP and YP.
WP and YP you want to compare? Okay.
Wait, what? I'm confused.
Well, yeah. See, okay. We'll stop here. We'll do similarity next week instead of rushing it through. Can we do that?
Okay.
Start with the same problem. It's just that similarity is a new topic, right? So we'll do
Yeah.
similarity next week, but please do finish length area, full chapter, review problems, and the review problems of congruent triangles. I'll put it out in the Google Classroom. Alchemist is also there. So you have enough work for this week. Any questions?
No. Goodbye.
Can I stop here?
All right, well.
Bye, guys. See you all next week, guys.
Bye.
Bye.
Yeah,
Thank
bye, ma'am. Bye, ma'am.